Welcome to qnawire.
Hello friends, in the given diagram there is a satellite of mass 1200 kg. You can see there is a mass 1200 kg which having initial angular velocity 0.05 I cap plus 0.075 radian per second k cap when two small jets are activated at points A and B. This is this is at here and this is here parallel to y axis. Then it producing the thrust of 50 Newton. We have to determine operating time for jet if angular velocity of satellite to be reduced to zero. B part, resulting change in velocity of center of mass given radius of gyration along x-axis, y-axis and z-axis 0.12 meter, 1.2 meter and zero point 0.9 meter. I have tried to draw the diagram but it is very difficult, so you should follow the diagram while doing the calculation from the book. Now let us see here. First we will calculate moment of inertia of the satellite along x-axis, y-axis and z-axis. So Ix will be mkx square. Mass is 1200 kg. Radius of gyration along x-axis you know. So it would be 1505.28 kg meter square. Along y-axis we can find mky square 1200 into its radius of gyration along y-axis is 1.200 square. So it will be 1728 kg meter square. Similarly, along z-axis, mkz square, mass is 1200, radius of gyration is 0.900. So it would be 972 kg meter square. Initial angular velocity, you know, it is given along x direction, it is 0.05 radian per second. Along y direction, it is 0, and along z direction, it is 0.075 radian per second. Initial angular momentum h g first, it will be I x omega x I cap plus I y omega y j cap plus I z omega z k caps. Excuse me please. Now substitute the value, so you will get I x is 1505.28 plus 0.05 I cap. This is 0 and it is 972 into 0.075. So initial momentum initial angular momentum you will get 75.264 I cap plus 72.9 J cap, 75 K cap. Y component is 0. K cap kg meter square per second. So this is equation 1. Final angular velocity is 0. omega 2 is 0. So final angular momentum will be 0. Position of jet A and B relative to center of mass RAG will be 1.2 I cap plus 1.8 J cap meter, and that of B jet it would be 1.2 I cap minus 1.6 K cap meter. Impulse you can find impulse from jets A and B. F delta T A J cap F delta T V J cap. Now applying the conservation of angular momentum, so we can write Hg1 plus Rag cross F delta T A J cap plus RVG. Here you are applying conservation of angular momentum, angular impulse theorem. You can say F delta T V J cap is equal to final angular momentum. From equation 1, 2 and 3, substitute the value here. So you may write 75.264 I cap plus 72.9 K cap plus RAG you have calculated 1.2 I cap plus 1.8 J cap cross F delta T A J cap plus RVG. RVG is 1.2 I cap minus 1.6 K cap F delta T V J cap, and finally its angular velocity becomes 0. Now computing, equating the components along I cap, J cap and K cap, you will find 75.264 minus 1.8 F delta T A plus 1.6 F delta V is equal to 0. Say this is equation number 4, and if you equate K cap you will find 72.9 plus 1.2 F delta T A plus 1.2 F delta V 0. This is equation 5. Solving equation 4 and 5. F delta T A will be minus 6.4518 Newton second, and F delta T V minus 54.298 Newton second. Since both components are negative, the negative bidirection, both impulse are negative component, thus the thrust of 50 Newton of jets A and B in along negative bidirection. So F is minus 50 Newton. So you will find time interval, operating time interval. You can find operating time intervals. We will calculate by using the equation 4 and 5. Time interval for A jet will be minus 6.4518 upon 50. So it will be 0.1290 second, and for jet B it will be minus 54.298 upon minus 50. So it will be 1.086 second. Now in B part we have to calculate change in velocity, apply impulse momentum equation. Impulse momentum equation F delta T A j cap F delta V j cap is equal to m into delta V. So from here you will find the change in velocity. This is 6.4518 j cap minus 54.298 j cap 1200 into delta V. So change in velocity you will find minus 50.6 into 10 to the power minus 3 meter per second along bidirection. That's all for it. Thanks for watching it.